So today is actually a good day to start with this because today is the start of the National Robotics Week. It's a 1 week robot festival out here all across US, and right now I'm in California and it has just started today. It goes on from this Saturday till next Sunday. So if you're interested in looking out what's going on in robotics, this is 1 week where all of the people come out of their lab with their robots and show off. There's a lot of parties on robots as well as a lot of events where they do a robot-based show and tell. So have a look at it. If you're interested, National Robotics Week, you can go to nationalroboticsweek.org, and a lot of events. Even I think there's an event in India too, so you can join in and possibly go and visit them. So to begin with, who the hell am I to give this seminar? So Manish approached me to do this seminar because I've worked with him before and known him for a long time. I have a background in robotics. I've done my master's in robotics as well as I've worked with a couple of robotics companies in US as well as in India. I've started a company out here called as MightyCarma, and also do a workshop as well as educational robotic thing called as iRoboticist.com. And I'm also advisor at two technical universities out here. One is ITT Technical University and Deborah University. And also taught at one of the university was. So to begin with, this class is just about, this seminar is just about how to get started or where to get started with. And one of the questions that I usually start with is, what is a robot? And how do you define a robot? Basically, a robot is any machine capable of carrying a complex series of actions automatically. And it can mean anything right from a dishwasher or cloth washer to a robot which can, a fan can also be called as a robot if it has some autonomous functions, as well as very highly complex machines like drones and humanoids. I can hear a lot of disturbance. Can everyone else mute their mics, please? Great. So feel free to ping me if you have any questions while we are doing this. So moving forward, I just want to touch upon basics of robotics today. So the idea is, what do you need to know to begin with robotics? Robotics is it's not a single field. It's not a single expertise that you can obtain. It is a series of a lot of things. You need to have some experience in electronics, mechanics, computer science, and one of the most important thing which is usually ignored is art. And you really need to know building a robot is an art. You need to understand how everything goes together, and bringing them all together and building beautiful products and devices is very important in robotics. So to get started, the very first and most important thing to know is that you won't know everything right off the bat, but you should not be intimidated by learning new things or being afraid of trying to learn new things. The best way to swim is to jump in, and I always ask people to do that. Is like, if you want to learn something, try doing it first. If you want to start with robotics, try building robots first. And once you start building it, you will learn a lot of things on the go. You can break down learning into several small steps. Out here you can see two of the pictures. These are really young kids who are barely 10, 11-year-olds. In fact, the one on the right is actually one of my students who was a 10-year-old. He attended one of the workshops with his dad, and he was teaching his father about robotics as well as programming, and his father was like just sitting out there to encourage him, and he had no idea what his son was doing. So it's never too late to start off with, as well as it's never too early to start off. You can always start by small things. You can start with a very basic robot and then add on to it. For example, if you're an electronics person, you can start with electronics. You can start with what you know best. If you're a mechanical engineer, start off with that. If you're software guy, start off with off-the-shelf programmable robot and start programming them to understand how it works. And if you're not an engineer, you can still build a robot. It's not very difficult. Robot is just a word given to abstract objects which people don't understand how it works, and you can actually start building with a very simple logic circuit also. So the idea is anybody can build a robot, but you should know where to start off with and what to start with. So what to start with is simple robots. There are a couple of robotic categories which you can start off with. One of the most simple one is beam robots. I'll explain what that is. Then you can have remote control robots or even toy cars, which you can break down and modify it as yourself to begin with robotics. Then one of the simplest and the most easiest way to have a motor and battery connected together, and I don't think I've seen a robot simpler than this one, where you just connect a motor and a battery together and put it on top of a toothbrush. Go check it out. This is called Bristle Bots. They are really cute. They're really nice, and very easy to build. Within 3 minutes, you can build a robot. All you have to do is connect a vibration motor with a battery and wish it on the top of a toothbrush head, and it's called Bristle Bot. Please do let me know if I'm going a bit fast or slow. If you have any questions, feel free to ping me online, and I can help answer along the way. So beam robotics is a field of robotics which is inspired by biology. Basically, Mother Earth. You can start off with small robotic applications like building an ant-like structure or a grasshopper-like structures, just getting inspired by these movements or their movements and how to replicate those. This guy known as Mark Tilden is called as father of beam robotics. He invented this field. And in this one, if you see, there is no computer science involved. So there is no software or programming required for building a beam robot. All you need to do is just build some small electronic circuits and put them on a mechanical structure. Make them look beautiful and be inspired by the biology. They just have 3 laws of robotics for beam robot. Protect the IS, feed the IS, and move the IS to better real estate. What that means is most of these beam robots are usually powered by solar panels or some battery, and they have to just make sure that they are safe so they don't bump into something, they don't fall off from great heights. So they have to avoid all those things, as well as they have to go and find the right amount of light so they can be charged, as well as they have to move to better real estate. So if there is there is some problem in the surrounding area, or if they are in a place where they can get destroyed, they have to move to a better place. Hello? If someone just joined. Okay. Thanks for muting the mic. We will gonna continue. We just started a few minutes ago. We are gonna record this whole presentation so you can have a look at what you missed later on. These are some of the beam robots. One of them is Walker. The first one is just a basic 2-motor device with a solar panel mounted on it. It can just walk by moving those 2 motors back and forth, and it looks like a grasshopper. The photo board on below that is basically, as the name suggests, it looks for better lights. Then there is an obstacle avoidance, which tries to avoid obstacles, and head, which just rotates towards the source of light. Cement is just a top which rotates around itself. These robots are very easy to build. They can be built within a matter of hours or sometime in minutes. All you need is just basic electronic components which can be hacked from day-to-day devices like your old TV remote controls or old radios, and you can easily build these devices. What you need to get started with a beam is just basic prototyping boards or breadboards, some motors, couple of sensors. Basic components like resistor, capacitor, transistor, which are not very difficult to get. Sometimes you can use logic ICs or battery and solar cell, as well as few wires. There are a lot of tutorials online if you want to research about this, start building this. The circuits are very simple for anyone to understand, so this is a great place to start with. The remote control robots are also not very difficult to find. You can find them in the toy stores, as well as there are specialized remote controls like the one shown out here, which are used for controlling remote control aeroplanes. This can also be used for controlling robots, or you can also use something like your TV remote, which is not very difficult to hack into. You need to have some understanding about how things work for this, and you have to do some more research about how electronics or sensors work in this case. But they are not very difficult. You can do this within a matter of days or maybe just a week max. You can start with off-the-shelf remote controls, and nowadays you can even start with smartphones. If you want to do a wired remote control, which is the easiest part to do, is just connect 3 motors to a battery and switches to control the direction. This was one of the first robots I started building it when I was in college, and we were participating in a lot of competitions, which is a good place to start with, good place to get inspired. Just the idea of participating gives you a lot of learning experience, And I think learning all these things is more important than winning in this competition, because you go there, you are out there, you try it out, and that's the most important thing, I guess. And that really taught me a lot and got me started into robotics. Building the structure, the common Indian tendency of JUGAAD. It's a very famous thing, and it's a very good thing to do with robotics to start off with. You don't really need to have laser cutters or really good, sophisticated looking robots. You can start off with cardboard, foam boards. In this cases, you can even start off with plastic or bottle caps, which make a great wheels, or you can, just hack a board. The one which you see out here are usually made with foam boards or with cardboards. You can even use the breadboard itself as the base, and you can connect robots to it. Building the structure, you have to be really creative. All you have to understand is what the mechanical system is. Just hack it and use that. Use what's available to you, cardboard box as a robot body. You can use jar tops as a great wheel, as I said. You can also hack into the existing toys. Don't break toys which your brothers or sisters are playing with, but the old toys which you owned, you can always hack into those, get some DC motors out of them, or also some batteries, LEDs, and capacitors. Really important for you to get started with robotics is open up everything which you're about to throw away. See what you can hack from it. Be a hacker, hardware hacker, software hacker, everything. Like, you have to have a hacker mentality to be a robotics engineer or to start with robotics. Another thing is set clear goals, what you want the robot to do. It doesn't have to be really high-end goals. It can be very simple tasks like just follow a line or avoid this edge of the table. It's called tabletop boards. But set those goals and work towards that. Define the purpose of the robot. Give a meaning to its life, and build on top of it. So if you have built a robot which is doing basic functions, or suppose avoiding the edge, but now you already have the structure. Now you can modify it, build on top of it to add more functionality to it. You don't have to build the structure right from the scratch every time you begin. So this will enable you to do development faster, learn a lot more faster, as well as give you a platform for you to hack into a lot of things. That's why you might have seen a lot of people use really huge bases for the robots that they can easily add and remove things from it. I would suggest using something like a old plastic plate as a base and then build onto it, which really helps you to expand your robot rapidly, learn a lot more things, and experiment with it very easily. And don't be afraid to make mistakes. You are going to burn few things, you're going to break few things, but that's how you're going to learn. Unless you make mistakes, you're never going to learn in robotics specifically. Robots, I think, should always be sensitive. One of the most important aspects which makes robots different from other electronic items is they have sensors. And that brings life back to the robot, that brings feedback back to the robots. And you really need to play around with simple sensors to begin with, and then you can add complicated sensors. Really like using light sensor and sound sensor to begin with. So you can just have a clap-based robot. When you clap, the robot should turn around. Or when you put light on it, it should follow the light, or something like that, which is very easy to build. Does not require very high-end components, but it's a great place to start with. And as I said, you can start with the simple one, add on to it, and so on. Once you have got the robot running, especially if you're doing just remote control robots, you have to build. It's easy. The next step should be where you use some logic circuit, gauge, transistor to give it some autonomous behavior, which helps the robot move on its own. It can be a very simple application, but it has to move on its own. So that's the next step when you go out from building just a motor with wires connected and battery connected to it. To next step where you have making autonomous. One of my favorite one is, as I said, is line follower or edge avoider robot, which are very simple to build, very low cost, and very fun to play with. And most important thing in robotics, it's really necessary for you to have fun. If you're not having fun, you're not doing it right. You need to make sure that you're enjoying what you're doing. If what you're doing is really getting you boring, then it's not for you. You need to start looking at some application or try to solve some simple problems in your house. It can be even a problem where you are really lazy and you want to fetch a glass of water from the kitchen. You can build a robot which can just go to the kitchen and bring a glass of water back for you. This concept is sometimes also used in the US called beer bots, where it fetches a bottle of beer for people, and a lot of people have started with that and really enjoy doing it. So the world is your oyster. You can start doing anything you want. this is where my presentation ends, but there are a couple of things we can do a follow-up presentation after this some point where I can show you how to begin with electronics in details as well as with microcontrollers or making more programmable robots using open source hardware as well as some other hardwares. You can get in touch with me through Facebook or Twitter, or you can go onto the website. There are a lot of things you can read about some of my projects in the past and so on. I also, me and Manish both are part of the Robotics in India LinkedIn group. You can join that if you have any questions. A lot of people on that group. We have 700 plus members right now. So, you know, it's really a community out there. You are welcome to join. I really wanted to thank Manish and our sponsor Sparker Innovations. These are some of the development boards they make. It's a great platform to start with robotics if you're doing some software-based robots, which I said talked about. Microcontroller based, we can do another webinar about this, but this is a great place to start with. Manish also has some workshops as well as some online blogging about how to get started with this, and you know, it's always a great start. At this point, I just wanted to thank Manish and Roboconhelp for helping us do this webinar, and I'll hand it back over to Manish. And if you have any questions, please